So the next topic in our Nugget series is called blockchain. What is blockchain? So blockchain by definition is called a distributed ledger. Right? A distributed ledger. And by ledger, it means a document or a database that contains a series of transactions recorded over time. And why is it distributed? Because it's a same copy of this ledger or document or database is maintained across multiple nodes. Right? And therefore it's a network of nodes. It's also called a blockchain network. And this N can run up to millions and billions of nodes in a network. Now every data that is, or every transaction that is added to this blockchain looks like, or is called a block. So say B, let's call this BI, and let's call this BI minus 1, let's call this BI plus 1, and there can be many there. So as you can see, it looks like a chain of blocks, and hence the name blockchain. Right? Now each block, for example BI, each block contains the transaction details, say for example A sends money to B. A is a sender, B is a receiver. A sends $100 to B, B receives $100 from A. Transaction details. Apart from that, it also contains a hash of its previous block. Right, so say B, so hash of its previous block I minus 1. Let's call this hx I minus 1. And using this information, it creates a hash for itself, bi. Let's call this h psi. So in effect, a block will contain its transaction details data, its own hash, and the hash of the preceding block. Right, so hx I minus 1, hx I minus 1, hx I minus 2, and so on for this hx I plus 1, hx I. Right? Now one of the fundamental tenets of blockchain is immutability. Now how does a blockchain ensures that the data is immutable or stays uncorrupted? Right, so say an attempt is made to corrupt data in this block, bi minus 1 block. Now if you try to change the data in this block, which means when you create the hash for that block, it will be a different hash. Now if this hash is different, this hash needs to be changed, or this block needs to be updated so that the chain is maintained. Now, as soon as you change this hash also gets changed, because this hash is created out of the data in that block and also the hash of the previous block. Now if you change this, you have to change this as well, or update this block as well. So this creates a domino effect, and every block thereafter has to be changed to keep the chain maintained. So that's how, and it's a very compute heavy operation. So that's how it's almost impossible to corrupt or doctor any data in a blockchain, and hence immutability is achieved. So generally speaking, there are two types of blockchain: permissionless and permissioned. Permissioned blockchain. So in a permissionless blockchain, as the name suggests, anyone and everyone can just sign up and be a part of the blockchain network, right? So any public networks, any public blockchains that you see around you, Bitcoin, Ethereum, Solana, they're all permissionless blockchains. So if I want to add myself to that blockchain today, I can just sign up and be a part of that network. And a copy of the database of the ledger will be shared with me, so I can see all the transactions that have happened so far in the blockchain, right? Without requiring any permission from anybody. So that's permissionless blockchain. So what if I want to add a block to that blockchain? I can view all the transactions for sure, but what if I want to add a new block to that blockchain? So a POW, a proof of work, needs to be created, which is basically a complex mathematical problem that needs to be solved to create the hash of this block. So a number of nodes compete to solve this problem. It's a compute heavy problem because it's a complex mathematical problem, and whoever comes first with the solution is rewarded, and the block gets added to the blockchain, right? So what is permissioned blockchain then? So permissioned blockchain is, as the name suggests again, the network is well guarded, is quite strict about who is to be added in that network. So every node that participates in that network are trusted by each other, or is trusted by each other, right? So strict trust and privacy policies are kind of cornerstones of a permissioned blockchain. Now you can even create complex privacy policies around what portion of data can be seen or accessible to a particular network. So if you want pieces of data to be blocked to a particular set of nodes, you can also do that. This is not the case for a permissionless network or permissionless blockchain. And this is quite a common case in business organizations where they want to keep their blockchains well guarded. So there is another important concept in blockchain called the smart contract. Smart contract. A smart contract is a piece of code that's executed whenever a block is added to a blockchain. So instead of using a POW or a proof of work, which is very computationally heavy, you can choose to use a smart contract, which is not only computationally lighter, but also it adds automation to the process. Right, so when a block is added to the blockchain, a smart contract gets executed to check if the block is meeting certain requirements and conditions as set in the code, and if it approves, then the block gets added, or else rejected. Right? So that's it. That's pretty much the overview of blockchain. Hopefully it gave you an idea what a blockchain is and how a blockchain works. Thank you so much.